Hey, hanging with us. Like, this video is going to be on solubility trends, so figuring out what salts are soluble and not, and then doing some qualitative analysis of solutions armed with that knowledge. All right, this topic is all about using this list, and you have this list in the data booklet or something similar to this, but gives you the solubility of common compounds in water. And what do we mean by soluble? Okay, is highlighted there. It means that at a certain temperature, remember all this, although we don't mention it that often, all this solubility stuff is temperature dependent. So at 25 degrees Celsius, if we call the salt soluble, it means that it will you'll be able to put 0.1 moles of it in a liter or more. Okay, if we call it insoluble or say it has low solubility, we're saying that means it has less than 0.1 moles per liter as a concentration when you try to dissolve it. Okay, so that's like the cutoff. That's what we're saying. So how to use this chart? You can see that this chart is mainly organized by anions. Okay, so you look at here and it's got all the different negative ions. Okay, and then it tries to show you what cations, what positive ions you could pair that negative ion with to get a low solubility salt or to get a high solubility or a more soluble salt. Okay, so it does that in each case with the nitrate, the halides, the sulfate, the sulfite, the hydroxide, and so on and so forth. And then at the top, it's got a couple of examples of more ubiquitous positive ions, cations, like all of the alkalis and the hydrogen ion and the ammonium ion, which are always soluble. That's just to try and help you as a shortcut and say, like, you know, hey, these would be on the always soluble list for every one of those anions I've highlighted in red below. Okay, so that's kind of how you use this list. So, for example, if I highlighted a certain salt, okay, and I said, all right, what about barium sulfate? Is barium sulfate soluble or not? Okay, where you'd start is you'd go and look at the sulfate ion, okay, which I'll highlight this in green. There's the sulfate ion, okay. And then you'd look and see where's barium. There's barium. So we see it has low solubility. So this has a low solubility, or we'd say it's insoluble, or we'd say it's not soluble. All this stuff means the same type of idea. It's going to have less than 0.1 mole per liter in any given solution. What if we looked at something like gold sulfide? Okay, how about this one? Is it soluble or not? Pick a different color. Maybe I'll use yellow so you can read it. Okay, so you go to sulfide. There's sulfide. And you say, all right, it's soluble with these ones, H plus, NH4, I don't see gold in there, so that means it has a low solubility. It's not soluble, okay? All right, whereas if we look at something like cesium hydroxide, how about that one? How about cesium hydroxide? Okay, for cesium hydroxide, let's go to the hydroxides, and we see that only the H plus, the NH4 plus, or the SR2 plus are soluble. But wait, also all the alkali ions are soluble. And if you go up here, cesium is one of those alkali ions. So don't miss this one. This one is soluble, okay? So don't miss those alkalis on there. I think that's one thing that confuses people a little bit. Don't miss the word alkali there. It just doesn't seem to fit in with that set, but it refers to all of these up top, okay? Okay, so here's an example of a question that would involve what we call a qualitative analysis. Okay, so a qualitative analysis means it's not going to have any real calculation to do. Okay, you're just going to be saying kind of a yes or no to this question. All right, so there's a beaker of lab waste, and this is kind of a realistic real-world scenario. And you know that lab waste may contain a silver ion, it may contain zinc ion compounds, or it may contain strontium ion compounds. Okay, so it could contain any of those three cations. Describe a procedure to determine if any or all of these ions are present. Okay, So what you want to look for is you want to look at this list on the left and say, is there some sort of an anion we could add, okay, as a salt that will actually precipitate, meaning it will make one of these ions over here on the right come out of solution as a solid, but it'll leave the other ones in the solution, okay? So in other words, you're looking for an anion that will have an insoluble product with one of these guys, but it will be soluble with the others, okay? And then what we can do is add that anion in, precipitate one of those cations out as a solid, remove it by filtration or by decanting and drying, and then do it piece by piece. Once we remove that one, we can do the same thing between the other two, okay? So if you look here, for example, and you just start one at a time. Nitrate, well, everything's going to be soluble in nitrate, so forget about that. Okay, chloride. Look through the chlorides. What you see is that we have a low solubility of silver chloride, but everything else is soluble, meaning that zinc and strontium are going to be soluble. So let's add a chloride, okay? So we're going to add, so step one would be add a chloride. What chloride? You can't just add chloride ion onto itself. You have to put it in with a salt. So what salt could we add it as without like messing up this whole result? Okay, we need a soluble salt and something that's not going to precipitate and it's going to be soluble all the time. So choose one of these guys would be the standard advice. Choose an alkali salt. So let's add NaCl, okay? So we're going to add NaCl. Or you could say add the chloride ion as NaCl, and we're going to do that in excess. We want to make sure we add lots of it so that we're not going to run out and maybe accidentally not precipitate all the silver, okay? If we do that, then silver chloride as a solid will precipitate from the solution, okay? Because we know silver chloride, according to this, is a low solubility salt, right? So that will precipitate. We then have to make sure we precipitate. Why can't I spell? Precipitate. Okay. We know then that we have to remove that silver chloride so that silver is out of the way and we can focus on the other two ions. So remove the precipitate, remove the solid by filtering. Okay, by filtration. Or you could say some other method, but I mean filtration is probably the simplest, all right? So that's going to be step one. I'm going to make this a little smaller so I can fit step two. Step two, now we've got the silver gone, okay? Now we're going to focus on something else, the zinc or the strontium. So keep on moving down your list. It looks like there's no zinc or strontium there, so let's move on to the sulfates. If we look at the sulfates, we can see that we have a low solubility of strontium, but not zinc, right? So we could probably add a sulfate in here, and that sulfate will precipitate the strontium, but it will not precipitate the zinc. So let's add sodium sulfate. Again, whoops, we don't put that on there. Na2, sodium sulfate. Again, sodium is a nice benign, or what we would call a spectator ion. We'll see that why we use that term in a subsequent video. But we'll add sodium sulfate to precipitate. What do we say is going to come out? Strontium sulfate solid. All right, and then we're going to remove that by filtration. Now, last but not least, we've got the zinc. Okay, so we got to remove zinc with something. Well, what's left here for the zinc? Let's see. Is there anything that has a low solubility with zinc, but not with others? Usually, I don't see one. So maybe actually we have to switch this up and do the sulfate step last. Okay, and because what I do see is let's do this one as step 3. And then in here, what I do see is that if we add hydroxide, see, it'll actually leave the strontium in as soluble, but all others will be low, so that includes zinc, right? So let's do that. Let's, step 2, add hydroxide as sodium hydroxide. Okay, precipitate. Of course, that's if it's in there. If these like it says, they may or may not contain them. If those metal ions are not in the solution, then obviously they won't precipitate, and that'll be that. But we add this, and it'll precipitate. Come on, Usyk, you can do it. What'll it precipitate? Zinc hydroxide, solid. I guess I need 2 of those. Get the formula right. We'll do that, and then we filter it out. Filter it out. Okay, so it has to be 1, 2, 3 in that order, because we couldn't, if we did the strontium first, there wouldn't be anything left that would isolate the other one. Well, I guess we could add, I guess we could have just added well, what could we have done? Now you pretty well have to do it this way. Could we have done the hydroxide at the end? Well, in theory, we could have done the hydroxide at the end. That's true, because if all of the strontium was already gone as a sulfate, then I guess you're just testing for, as long as you did it in excess here. I might be uncovering something really important, but as long as you did it in excess here and you knew all the strontium was confidently gone, you could go ahead and add hydroxide then, and any hydroxide compound that came out would be zinc. So anyways, you could do it 1, 2, 3. You could do it in the original order, or 1, 3, 2. The point is here, and this is really important, there is more than one right way to do this. There is no one absolutely correct way to do this. There are a multitude of different ways, and there's a multitude of different salts that you could add, as long as your salt has a cation that's totally soluble and it's not going to be involved in the reaction. Hopefully this makes sense to you.